All right, hi there. This lesson is on finding the surface area of a sphere and also problems involving partial surface areas of spheres. So one of the things that of course we will need to know is how do we actually calculate the surface area of a sphere. So looking at spheres, the formula to calculate the surface area is shown here. And so we have S for surface area equals 4 times pi times the radius squared, 4 pi r squared. And one of the things, of course, that we also need to know is how do we determine or find the radius of a sphere. And that's described up here. So the radius is measured from the point at the center of a sphere to the surface of the sphere. And we can see that here from the center of the sphere to the surface of the sphere this way, or from the center to the surface of the sphere this way. Any direction from the center of the surface will give us the radius of that sphere. All right, let's look at this problem. So in this example, it says that the Earth's radius is approximately 4,000 miles. It also tells us that about 2/3 of the Earth's surface is covered by water. You may or may not have known that, but that is true. We are to estimate the land area on Earth to the nearest square mile. So we don't have to do any unit conversions because we're looking at a radius in miles. And what we do have to understand, though, is then if we are to estimate the land area, what portion of the Earth would be represented by land. So we're looking at understanding here that if 2/3 of the Earth's surface is covered by water, then 1/3 of the Earth's surface is covered by land to give us a total of one whole surface of the Earth. So now that means that we are going to figure out 1/3 of the Earth's surface area. So we want the 1/3 of the Earth's surface area. The measurement that we need for area or surface area is, remember, the radius, which we have 4 pi r squared for our formula. So our radius is given to us earlier as an estimate of approximately 4,000 miles. That's a little higher than the actual Earth's radius, but it's rounded to the nearest thousand in this case. And so then we're looking at understanding if we want 1/3, that our surface area would then be 1/3 times our surface area formula of 4 pi r squared. And so that is going to give us 1/3 times 4 times the pi times our radius of 4,000 miles, quantity squared. And we have talked about this means that we are squaring the 4,000 as well as the miles, which will give us our square miles of our units. So using our calculator to do this calculation, we come up with, and again, remember we're rounding to the nearest square mile, which would be the whole number position. So what we get is about 67,020,643 square miles. And the abbreviation for miles is MI if you're going to use it. And then we would be able to state our conclusion here. So we're estimating the land area on Earth. So the land area on Earth is about 67,020,643 square miles. All right, so the next problem here is a practice problem. So this practice problem I put in your guided notes. You can pause here, take some time to work out the practice problem. Here is the solution to this practice problem. And this next example. So in this next example, it says The size of a cultured pearl is typically indicated by its diameter in millimeters. This is important because it tells us how we interpret the description of a cultured pearl, that the millimeter amount represents the diameter of that pearl. The question here then says, how many times as great is the surface area of the 9 millimeter pearl compared to the surface area of the 6 millimeter pearl? So you may understand these types of problems. When it asks us how many times as great is one thing of another, we actually compare them through the inverse operation of multiplication, which is division. So we are actually going to figure out what the surface area of the 9 millimeter pearl would be and divide that by the surface area of the 6 millimeter pearl. And whatever value we get here, that's the multiplying factor for how much larger, how many times as great the 9 millimeter surface or 9 millimeter pearl surface area is from the 6 millimeter surface area pearl, or pearl is surface area. So here we have to remember our 9 millimeter pearl. That 9 millimeters would represent the diameter of that pearl, and the 6 millimeters represents the diameter of that pearl. In our surface area formula, remember, we use radius. We have 4 pi r squared. So our radius, remember, is half of the diameter. So here our radius r would be 3 millimeters. And here our radius would be half of 9, which is 4.5 millimeters. All right, so looking at this, we're now looking at this being equal to 4 times pi times the radius of the 9 millimeter pearl, which is 4.5 millimeters, quantity squared, divided by the 4 times pi times the radius of the 3 millimeter radius, quantity squared. Now, mathematically, you should understand, because this is multiplication here, and all multiplication, that the 4 and the pi are factors in each of these calculations. And you can actually reduce them as common factors, and that actually simplifies your mathematics. So the 4 is reduced to 1. The pi is reduced to 1. And so really now what we are left with is this calculation of the 4.5 millimeters quantity squared divided by, all right, so also then divided by our 3 millimeters quantity squared. So we're looking at our 4.5 squared, our 3 squared, and using our calculators, that should give us 2.25. And the units actually of millimeters squared on both of these also reduce out. So we really only have this multiplying factor. And so now our conclusion would be the surface area of the 9 millimeter pearl is 2.25 times greater or as great than the surface area of the 6 millimeter pearl. All right, let's look at this one. So here it says a spherical water tank is 21.5 feet in diameter. The corrosion-resistant alloy skin of the tank is 1/8 inch thick. Estimate the amount of alloy used to make the tank to the nearest cubic inch. So this one's a little different. Notice it says cubic inch. That's a volume quantity. So what this is saying is that if we were to peel off the skin of this water tank and flatten it out, we want to know what the quantity of that is, not only in cubic inches. So we need its area, and then we take its area. So we take our surface area, and we multiply it times the thickness. And that will then give us the cubic inches, as long as, of course, we take our diameter here, which is in feet, and convert it. So that's what we're going to do first. So we're going to convert in our first step. So we take the 21.5 feet and convert it to inches. We know there are 12 inches in 1 foot. And that gives us 258 inches. And this, remember, is our diameter, now in inches. So now I'm going to change that, or calculate my radius, which would be half of my diameter. So I take my 258 inches and I divide it by 2. And this will give me a radius of 129 inches. Now I can calculate my cubic inches. So I take my surface area times the thickness. So that's going to be my 4 times pi times my radius of 129 inches, quantity squared, times my thickness of 1/8 of an inch, which is right here. Now when you do this in your calculator, it's 4 times pi times 129 squared, and then you can do times 1 divided by 8, or you could just do divided by 8. And rounded, remember, to the nearest cubic inch, we are looking at 26,140 cubic inches. Then we can write our conclusion. So this again is the estimating the amount of alloy used to actually make the tank. So the alloy, which is a metal that's composed of different types of metals. So the alloy used to make the tank is about 26,140 cubic inches. All right, so now we also can, in certain problems, look at finding the surface area of a hemisphere. And sometimes we want to include the base, which is the circle on the bottom. That's our base. And sometimes we don't. We just want the half of the sphere. So if it's just half of the sphere, we see here we're looking at 2 pi r squared, which is half of 4 pi r squared. If we want to include the base, which is a circle, then we're taking our half of the sphere, 2 pi r squared, which is half of the 4 pi r squared, and adding area of the circle pi r squared, and 2 plus 1 pi r squared gives us 3 pi r squared when we do include the base. So here in this problem, we are looking at a dome that has a diameter of 73 feet. It's in the shape of a hemisphere, and it's covered with solar panels. We want to estimate the square feet of solar panels. What we have to understand is that the solar panels wouldn't be on the bottom of the dome because that's not going to see the sun. So this would be surface area of just 2 pi r squared. And our radius would be half of our 73 feet diameter. So this gives us 36.5 feet. And so our surface area, which is covered with the solar panels, would be 2 times pi times 36.5 feet, quantity squared. So then in our calculator, we'd do 2 times pi times the 36.5 squared. Here we are rounding to the nearest tenth of a square foot. So our calculators should be giving us 8,370.8 square feet for what's covered with our solar panels. So our conclusion would be about 8,370.8 square feet of solar panels is needed.